this is Mrs. Peck showing you how to fill in page 7 and the top of page 8 of your notes on Unit 12. This really just talked about what are like some unstable isotopes have too many neutrons or not enough neutrons or are too big. Well, so how can you get a feeling for what ratio between neutrons and protons is making them stable? That's what this band of stability is showing you. If you are looking here, you have the number of neutrons listed and the number of protons listed, and every single dot here is indicating a stable isotope with the appropriate number of neutrons and protons. Now, what you notice is that in the very beginning, maybe up to element 20, somewhere in that range, you have a very close resemblance of that line, which is showing you same number of protons as neutrons. But then as you go higher up, as you get to larger and larger atoms, you get to a point where you have more neutrons than you have protons. So that is something that you should take out of that. So in the notes here, it tells you that on the lower elements, usually below 20, you have this 1-to-1 ratio, so your mass number ends up being double of the atomic number for those smaller atoms in a 1-to-1 ratio. And then if you go beyond that, you tend to have more neutrons than protons. Now I know that your notes have something in addition to that talking about the ratio again. Ignore that, you can put parentheses around that. It's just a mathematical thing to express the same idea. Good. Also, I know that the formatting here is a little bit off. That's from copying it over into this system. So your notes are appropriate for how these isotopes are written. Good. Then you have one more piece of information. You also saw that some atoms are simply too large, and there is kind of like a cutoff number, and that is element 83 is the last element that has stable isotopes. Anything beyond that, that is larger than that, does not have any stable isotopes. All of their isotopes are radioactive, are unstable, and you can see that in your reference table, in the periodic table, by looking at the atomic mass of those elements. Any element that only has unstable isotopes, where every single isotope that exists in nature is unstable, there is no stable one, has the atomic mass written in parentheses as a whole number. And if you look into the key, it tells you that means that this is either the most common or the most stable isotope. Most stable implies it's still not stable, but it is the one that lasts the longest.